Bay Area, ACM, has founded it in
I want to ask you about a favor, a microphone for the streaming only.
Sure.
If you don't mind, this can go, for instance, here. And you can put this anywhere in your pocket. It is now on. Thank you so much.
We have a monthly evening seminars, general computing default on third Wednesday of the month, and data science, SIG, default on fourth Monday of the month. And it's a great opportunity for networking, announce jobs, and get hired. We have both meetup site for the regular meetings. Please go on there and register for food estimate. And we do have YouTube, and for all the technical talks we actually put on YouTube. Right now it's over 160 talks already. Upcoming events. Real-time monitoring of Twitter's network. Twitter's network infrastructure with Henrion, which is Monday on June 24th, coming up by Julie DeLunch at Warm Labs. And the next talk in July is Inside the Black Box, how does a neural network understand names, which is, the speaker came from the Netherlands. On Wednesday, July 17th, at the Palo Alto Networks. And then on July 22nd, we have from a rapid model development to faster production development, the best practice in data science. It's by Monsong Li. The talk is at Warm Labs. The next one is is on the computer architecture, is emergence of RISC-V computer architecture, embedded applications and machine learning acceleration. It is scheduled on Wednesday, August 21st by Karen Gangnam, and is joint event with Valley ML.ai. And we're looking for location sponsors for it. Whoever have a lead, please talk to me. We do have dog price. Do we? I'm not quite sure yet. Books, yes, we do. Okay, we do have dog price for today. Mostly it's on data science from our long-term sponsors from O'Reilly Media. And we are also called for volunteers. Normally volunteers can start with a small area to help. We have a volunteer dinner, normally the first Monday of each month. Is a great way to get networks and influence what we're doing. We do looking for a membership chair. I look at this, I see my editing goes downward. Did not reflect my change. But anyhow, we needed people help on the registration, membership services, recording people renewals, and come up with a real idea, find the member benefits, and then give out the discount. And one of the discounts coming out is looking for, we have a job postings online pretty soon. Also, we're looking for, regularly looking for training class TAs and the judges for science fair, which is, I think we'll wait on that. We also call speakers, which dates posted on the meetup page, call for speakers. So for speakers, please repeat the audience questions for the video recording. And for audience, please keep question to 30 seconds. And any announcement from floor? Yes.
So I run the PDS, which is Professional Development Seminar series for ACM. It's a really fantastic way for you to gain exposure to new knowledge. If you're continuing in your current role, you want to expand to new areas, or you're looking to switch. Our past PDS events have been one day. It's very nominal, like $125 for members. It's discounted, and I want to get a show of hands of what topics are of interest to you that you think is worth your time and effort being there. So one is on, so if I can just quickly shout out a few topics and you can raise your hands, it'd be really helpful. One topic is on transfer learning, machine learning, transfer learning. Is that too advanced?
Meta learning also, is that another name for it?
It is, okay. Meta learning. Okay. So not a huge show of hands. How about advanced Python for data science? Some. Okay. And how about some other programming languages like R for data science? Some equal now. Okay. And how about taking machine learning models and deploying them on the cloud and the whole shebang from start to finish? It's a pretty meaty topic for like a single day, but we try to do it. So we just want to. Okay, any other topics that people want to shout out if you're interested in joining in, if this would be of interest to you?
What about Julia?
Julia?
Why?
Yeah, no, it's fantastic. How about Julia? Not the actress? Okay, we should talk. I'm a fan of that language. Okay, all right, thank you so much.
Okay, anybody else? Do you have any more announcement?
In case you missed last week's ACM's Data Science Summit, they did stream it and it's available online now if you want to see some of the talks. I tweeted it recently, but you should be able to find it easily.
I just have to ask that we have potentially getting Hadley Wickham to give a one-day seminar. Anybody's interested in having Hadley Wickham come? He's an R data scientist guru. Anybody heard of him? Okay.
Okay, anybody else?
Colin, did you want to ask me? Yeah.
If you have a job, this is a good time to say so.
Yeah, okay. Well, I do indeed. Hi, I'm Colin Little, the CEO of Outlook. You can look us up online. There's about 95 employees at present. We're doing well, and we're looking to hire people in the AI area, in particular for contract lifecycle analysis, clause analysis, risk ranking, metadata extraction, etc. So, if you're interested, please contact me directly. My email address is colin, C-O-L-I-N, at Agiloft, A-G-I-L-O-F-T, or Alpha Golf India Lima Oscar Foxtrot Tango, for those who prefer that. And look forward to hearing from you. Thanks.
Anyone else? Anyone else? Any more? Okay, no more. You have to wait for next meeting then. Okay, go ahead.
Okay, very good. So Leanna asked me to introduce our speaker tonight, and I'm very excited to do so because he and I have been each other's closest colleague and collaborator for the last 20 years, actually more than that. So as many of you have probably heard, Dr. Henrion is the most recent recipient of the Frank Ramsey Medal, which is the highest honor that the Decision Analysis Society awards. And I was at a talk at Stanford last year when I heard a speaker say that the Ramsey Medal is the closest thing the decision sciences have to the Nobel Prize. You know, there is no Nobel Prize in data science or decision sciences. Oh, okay, is that better? Yeah. And so, as you can imagine, with such a prestigious honor, Max has a long list of contributions and achievements, and I'm hoping to take a couple extra minutes of this introduction here to just cover some of those, because I think they're pretty interesting. So the award committee for the Ramsey Medal cited his contributions to the theory and practice of decision analysis, to the combination of that with artificial intelligence, to improving energy and environmental policy decision making, to real-world applications, education, and public awareness. So his primary role nowadays is that he's the CEO of Lumina Decision Systems here in Campbell and Los Gatos. And I guess somehow he must moonlight or something because he has all these other roles up there too. He's an adjunct professor at Carnegie Mellon University, a consulting professor at Stanford University.
I have two.
He's on the Scientific Advisory Board for the Environmental Protection Agency. He's active in the Citizen Climate Lobby. And back in the late 90s, when the internet was in its big boom days, he was formerly the vice president of decision technologies at Ask Jeeves. So he did a degree at Cambridge University in Natural Sciences, a master's in design in the Royal College of Art in London, and then he went stateside to do a PhD in engineering and public policy at Carnegie Mellon University. And after he finished his PhD, he became a professor there. And during that time, he co-authored the book Uncertainty along with Granger Morgan. And this has become a super influential book in many circles. And it deals with the assessment and representation of uncertainty as probability distributions and how to apply that to decisions. Also, while a professor, he and his students developed the precursor of what would eventually evolve into Analytica. And after a few years, he was eager to apply that to some real-world problems, not just academic ones. So he and a student moved out to Silicon Valley in 1991 and founded Lumina. And he got to work doing a lot of very interesting things. And a few years later, in '96, Analytica was launched for the first time as a commercial product. And since then, it's been used by over 43,000 people, mostly analysts and data scientists in many dozens of different industries. So, now, even with all that, what I think is really the super impressive thing about Max are the accomplishments he's had in the many dozens of real-world decision support models and applications that he's created while leading the consulting practice at Lumina. And this slide kind of depicts a handful of those. It's definitely a subset. And every one of these projects is just amazingly interesting. And I kind of want to just give you an idea of the breadth of these, because it's also, the breadth is amazing as well. So it starts at the top left there with an evaluation he led of the Clean Air Act of 1990, which reduced kind of the effectiveness of it. That was an act that reduced acid rain and sulfate and nitrate emissions in the U.S. Scheduling of space shuttle maintenance between missions, evaluation of the viability of a proposed $13 billion satellite constellation. He developed a tool to manage the production facilities in oil fields, accounting for 30% of worldwide production of the second largest U.S. oil company. Along with 8 national labs, he collaborated to build a model that evaluated or that predicted the effects of investing Department of Energy research dollars in 38 different potential renewable energy technologies. Then an assessment of the impact of Canadian cow flatulence on global warming gases. As you know, methane is a significant global warming gas. Forecasting the changing composition of the U.S. vehicle fleet over the next several decades. Working with the World Bank and the ministers of Nigeria to develop a 20-year energy plan for that country. That was an amazing job that he really took leadership of, and it was a real headache. They were really hard, but that was incredible. Today, I think pretty much every utility company in California and several hundred other organizations that are interested in putting batteries on the California grid are making use of StorageVet to analyze those options, and he was a key architect of that. And in 2014, he was awarded another very prestigious medal. Actually, that one came first, but that is the Decision Analysis Society's Practice Award. And that's given to the best decision analysis application. In this case, it was for a project that led to a plan and new legislation for how to decommission the oil platforms off the Santa Barbara coast. And that project was so interesting, it inspired a documentary filmmaker to make a documentary about the project as well. So lots of interesting stuff there, a lot of interesting background. And so with that, I'm going to turn the entertainment duties over to Max, or to Dr. Henrion, I should say, right? Okay. And you have a wireless mic, right?
I have. I'm totally mic'd up.
Okay.
Wow. Well, thank you, Lonnie. That was kind of astonishing. Who is this guy, anyway? Can I live up to him? Let's see. Will it recognize me? So it really is a pleasure to address this group. When Liana invited me to talk and asked me to send an abstract, I sent an abstract of a kind of rather standard talk that I'd been giving, and she ignored that and found a couple of blog articles and wrote a much more interesting abstract. And I looked at that and said, I'd kind of like to give that talk. So that's the talk I'm going to attempt to give. I hope you will also find it more interesting. It was a little more work since I had to create something new here. But it is based on a few things that I've written. So this is kind of the core of what I've been involved with over really my whole professional life. Human intuition. How do we make decisions? How do we make judgments as individuals? Decision analysis as a technique, a set of practices to try to help us do it better. And the value of information, which is kind of one of those techniques that comes out of it that I think might be of interest to a lot of us. So I've always been interested in this question ever since I started using computers, which was a little while ago. Could they actually help us make better decisions? And I'm not so interested in artificial intelligence per se, replacing us, but rather in what's often called intelligence augmentation or intelligence amplification. And most of you probably are aware, for example, of Doug Engelbart, the inventor of hypertext and the mouse, who really, I think, came up with the phrase intelligence augmentation. And there's a nice book some of you may be familiar with by John Markoff, comparing AI and IA. So first question is, well, do we actually need help? How good is human intelligence? Back when I was a grad student at Carnegie Mellon, I had a sort of interesting experience. I took some classes in computer science and artificial intelligence. People were looking at questions like, how do we recognize a cat? Could we walk through a room, understand speech? And back in those days, what was stunning, I think, to many of the AI researchers was just how hard that was. And the conclusion, I have a picture of Alan Newell and Herb Simon here, who were among my teachers there, who were an early winner of the Turing Award. The conclusion is kind of human intelligence, the more you study it, the more amazing it seems to be. How could we possibly do these things? Then I took some other classes from cognitive psychologists, some of them actually inspired by Herb Simon, who notably came up with a notion of bounded rationality. And I didn't take classes directly from Amos Tversky and Danny Kahneman, but from various of their students and associates, like Baruch Fischoff, and Robin Dawes. And they, as psychologists, looked at human intelligence, human decision-making, things like how do we estimate the probability of an event? How do we choose who to hire or what grad student to admit to college? Because it's kind of psychology academics worry about that. Or how does a doctor decide what medical test to recommend or if it's worthwhile? And they typically compare human performance with some kind of simple probabilistic model, simple statistical model. And their conclusions are kind of diametrically opposite. Human judgment is fundamentally flawed, biased, incoherent. And I'm sure many of you will be familiar with Tversky and Kahneman, and there are many other psychologists that have followed them. So, how do we reconcile these two views of our minds, our brains? And that kind of got me going. And are they studying the same creatures? So how well do we make decisions, as an example here? And I took a look at one of my bookshelves, which you have a picture here, and that's only one of them, which has various volumes published. Well, immodestly, I have my own book at the extreme left, but books mostly by psychologists or journalists writing about psychology of judgment and documenting, again, how poor we are. And I mean, one of the interesting things to me is over the last 10, 20 years, suddenly there's a lot of popular interest in it. These are mostly popular science books that many of you may have read. I don't know. How many of you have at least heard of and perhaps read some of the Danny Kahneman book on the right, Thinking Fast and Slow? Okay, so it looks like maybe a third. And Richard Thaler's book, Misbehaving, and Kahneman's book, Thinking Fast and Slow, they both won the Nobel Prize in Economics for their work, which is kind of amazing because, economists, as famously have this model of the way humans make decisions as kind of these econs, these optimal, rational decision makers, which is completely blown apart by the findings of these guys. But nevertheless, the economists on the Nobel Prize committee, perhaps, well, having started with Herb Simon a while before, decided that maybe some psychologists should get a look in. So, okay. Kahneman talks about two decision-making styles. And I think this maybe starts to help us think about this apparent paradox between, the amazing mind and the appalling and flawed minds that we have. So he contrasts system one, the brain's fast, automatic, intuitive approach, which works for well-practiced tasks, like walking through a room, recognizing cats. And we're pretty good at that. We've had a lot of practice. And then the system two, the mind's slow, analytical mode, where reason dominates, that we apply to unfamiliar tasks. Well, hopefully reason dominates. Sometimes reason dominates. But we have to think. And some people looking at this saying, well, I don't know if some of you might have read Malcolm Gladwell's book, Blink, in which he points out that for many tasks, we can just, we have an immediate gut reaction, which is a good reaction. We immediately recognize something. We don't even know how, like riding a bicycle, recognizing a cat. But many of us are seduced into thinking because we're so good at those practice tasks, we are therefore equally good at the unfamiliar tasks, dealing with new situations and handling a lot of uncertainty. And the New York Times review had a pretty nice summary of this point. If you've had 10,000 hours of training in a predictable, rapid feedback environment, then blink. Your gut reaction is good. In other cases, think. So here's another way of thinking about decision-making styles. May I recognize this guy and maybe that guy. Trump's first Secretary of State, Rex Tillerson, was interviewed about decision-making. I thought it was pretty interesting. He said, I'm an engineer by training. I'm a very systems guy, process, methodological decision-making. I've had to build a relationship with President Trump for him to understand how my thought process works. And then he said about his boss, he makes decisions in a very different way than I do. He's an entrepreneur, different mindset. Doesn't mean one is better than the other, I've had to learn how he processes information and how I can give him advice that makes sense to him. So, whether or not Tillerson was a good diplomat as Secretary of State, he obviously was somewhat of a good diplomat in dealing with his boss and talking about him. Maybe not good enough, though. So I think, this seems to imply that there's really two different kinds of people, and there are different kinds of people for sure, but I think all of us sometimes do this kind of slow, systematic thinking, process-oriented thinking, and sometimes do this kind of gut instant thinking. It's a kind of a matter of which we choose when, and what is appropriate when. And obviously one worries that the guy on the right here, when it comes to making a decision about whether to bomb Iran, let's say, might not go through this carefully considered process. But maybe he will, or maybe he'll be advised by people that have. So let me take a step back here. I'm going to be talking mostly about decision analysis. It's based on decision theory. Now, how many of you have had a class or maybe read a text that kind of has the basics of decision theory? Okay, maybe a quarter or so. So I'm not going to give you the equations. I'm just going to kind of talk about some of the essence here. So decision theory purports to be a theory of rational decision-making under uncertainty. And it treats uncertainties using probabilities, usually what one might call personal or subjective probabilities. It recognizes that when we're making decisions under uncertainty, the uncertainty is based on, when I'm making a decision, what I know and what I don't know, and argues that the best way for me to represent those uncertainties is in terms of a probability. But it's not an objective probability that you can go out and measure. It's a way that I can express how much or little I know about the issue. And then the second part is utility, a way to express my preferences. And these things are ultimately based on kind of operationalized by willingness to take bets among different options. And there's a set of basic axioms that von Neumann and Jimmy Savage and Cox and others have put together in slightly different ways, that if you look at them, and I'm not going to go through them here, but some are like transitivity. If I prefer A to B and B to C, then I should prefer A to C. Things that seem kind of obvious, actually. And if you buy into those axioms, like Euclid's axioms of geometry, then the conclusion is there is such a thing as probability. That's the best way to express uncertainty. There's such a thing as a utility, as a measure of preference between options. And if you want to do the most reasonable thing, you should try to maximize your expected utility, the product of the probabilities times the utilities of the different uncertain options. And this was all put together. Well, John von Neumann, I'm sure you all know him well, as arguably the most brilliant mathematician of the 20th century, who invented the modern concept of the computer, often known as the von Neumann machine, and so on. Some of you might have heard of Jimmy Savage, who was a statistician that built on von Neumann's work and developed this further axiomatic framework, and it especially emphasized the personal subjective nature of probability. And if you're like me, you might not have heard of Frank Ramsey, at least not until I got the Frank Ramsey medal, and I thought I better find out who this guy was. If you have a background in mathematics, you might be aware of Ramsey theory, branch of combinatorics. He was active in the 1920s in Cambridge in England. And he also, in addition to developing the first version of decision theory, which was kind of ignored until von Neumann and Morgenstern reinvented it 20 years later, partly because it was published posthumously. He also made major progress in economics. He was a student of Keynes, although Keynes believed that probabilities were only objective, and Ramsey ignored his advisor on that topic. He also apparently fell in love with the wife of one of his other benefactors, which caused him a lot of grief, and he was worried that it would interfere with his academic productivity. So, he went to Vienna to be psychoanalyzed, which in the 1920s was kind of the thing to do by one of Freud's disciples. Apparently it worked out pretty well because he was amazingly productive for the next few years. He also, while he was there, met Ludwig Wittgenstein and learnt German so that he could translate Wittgenstein's Tractatus into English, arguably the most important work in analytic philosophy in the 20th century, and invited Wittgenstein to Cambridge to do his PhD, which turned out to be Tractatus. And the kicker is, he died when he was 26. So it's kind of a hard act for anybody to follow. Anyway, so the main topic here is, what is decision analysis? Now, how many of you have taken a class or read a book about decision analysis? Okay, about 20% maybe. So, but clearly, presumably you're interested or you wouldn't be here today. So decision analysis, one way to describe it is as applied decision theory. You take this kind of mathematical theory, these probabilities expressing uncertainty, utilities, the focus on decisions, and you try to make it work in the real world, which turns out not to be quite as easy as maybe some of the theorists expected it, but there's been practicing decision analysts for about 60 years that have developed a variety of methods and techniques and tools and practices to make this a practical thing to do. And I'm going to talk briefly about some of these and emphasize that it's a professional practice. It's not just kind of something you can learn in school, but to make it work, you really need to develop this practice. And I'll talk a little bit about some of those. And by the way, I'll end this with talking about a particular case study going back a little while to kind of illustrate some of the key points here. So you can think of decision analysis as being a toolbox of techniques. So if you've ever heard anything about decision analysis, you've probably heard of decision trees. And the trees that identify the decisions and the uncertainties, typically each are discretized, and the endpoints of the tree are the value of the outcome that you receive if you walk down that path, make those decisions, and then the uncertain quantities turn out that particular way. And you try to make decisions early on that will be sequentially the right thing to do, maximizing your expected utility. Then a second representation is influence diagrams. It's come a little bit more recently. How many of you have heard of influence diagrams? Okay. Not too many, but that's good because I'm going to talk about them, and I kind of think that is one of the more important things, or certainly I found it extremely useful. There's sort of multi-attribute models. So when you are working with a decision problem where there's a bunch of, you often have multiple objectives. You want energy that is cheap, that is safe, that doesn't create carbon dioxide or other pollutants in the atmosphere, and that you want it now, okay? Well, different types of electrical generation or other energy have different attributes, and so So how do you make a balance between them? So multi-attribute model provides a kind of systematic way for decision makers, for stakeholders to express their perspective on how the relative importance of these different objectives, and so that you can come up with a decision that somehow is the best at satisfying those sometimes conflicting objectives. Sensitivity analysis, so key concept. So when you're building these models, you have numerical probabilities, utilities, they're complicated quantitative models. And each number that you put in, you feel a little queasy, like, really, I put in 0.3, should it be 0.4? I know you guys, the numbers you deal with are all exactly certain, right? Joke. So the question is, which of these numbers, if you change them a little bit, does it make any difference to the conclusion? So that's what sensitivity analysis is about, as I'm sure you well know. But it's kind of a core concept in decision analysis, realizing that the numbers we're using, some of them are, expert judgment. Another way to say that is kind of they're made up, but, hopefully made up in a sensible and carefully considered way, but still judgment. Or they may be numbers that you've measured somewhere, but there's noise and so on in them. So how much does it matter? Is it worth putting more effort into getting more accurate numbers, or is that fine for the decision you care about? And typically we express the uncertainties using probability distributions and might use Monte Carlo methods to propagate these distributions through the model. And finally, the expected value information is a particular technique for really doing a kind of sensitivity analysis, but it's asking how valuable would it be to get a more accurate value for each quantity. And I'll talk a little bit more about that in a moment. But the first thing is, sort of the basic of decision analysis is distinguishing variables. If you're putting a spreadsheet together, you just have cells. Maybe it's a model for your personal finance. Maybe it's a model for your company projecting, trying to help evaluate whether to develop or release a new product, how much to put into marketing, how much to put into development, whatever your decision problem. So first thing is, what are the objectives? Maximize net present value. Well, that's kind of simple, but it's probably, maybe in reality, more complex. Your decisions. How much do I spend on marketing for this product? Do I actually launch this product once it seems to be in shape? When do I launch it? Uncertainties. Will people like it? How much will they pay for it? When will our competitor come out with something better? Whatever it is. And then there's the data. But you all know about the data, so I won't say anything more about that much. So then what is an influence diagram? So it's really just a diagram that has nodes showing these different variables. So there's decisions, intermediate variables, objective, and the arrows are influences. They might be just simple mathematical relationships. They might be conditional probability relationships. And at least in the software we have, we need to deal with large and complicated models, so we have modules where these thick outlines, these nodes with thick outlines, you open them up and then there's another diagram inside. And these have some chance variables, the ovals again, so on. And this, we really like this representation. I mean, it was originally developed by decision analysts to sit down with our clients and figure out, okay, well, what are the things that we care about here? What are our objectives? What are the decisions? So on, in a very visual way as a kind of facilitation tool. But we also, it's pretty nice as a tool within a modeling environment, and this is an example model. Lonnie mentioned a project we did for the Department of Energy, trying to project, what would the US vehicle fleet look like over the next 25 years? How rapidly will electric vehicles be adopted, biofuels, so on. And this is the top level view of that model, and then we can kind of dig into a particular module. Oh, here's a hierarchical view. Dig into the vehicle fleet model. It has further sub-modules and, going in 4 levels deep. So each diagram should be simple enough to be cognitively graspable, even though the model as a whole may have, thousands of such variables. And each of these variables may be a multidimensional array with thousands or millions of elements. But the point is trying to make the thing graspable, understandable. That's really the core. Another technique is tornado diagrams. I kind of talked a little bit about sensitivity analysis. The tornado diagram, so-called, if you arrange the variables so that the most sensitive one is at the top, it kind of looks a bit like a tornado to some people. But what this is in this example, the horizontal axis is the share of electric vehicles, plug-in electric vehicles, as a share of total US sales. It doesn't say, I think in the year 2023. And then in our model, we have all these uncertain variables that are listed down the left-hand side that you probably won't be able to read that well, but you don't need to. And you say, okay, well, if we take each variable and change it from a low plausible value to a high plausible value, holding all the other variables that are kind of intermediate, most probable value, how much effect does it have on this outcome that we care about? In this case, let's say it's a electric car company, share of PV sales. And if we look, the top variable is oil price. And it's interesting that the price of oil dominates all the other variables. That's not something that many of us have control over, although one can imagine right now that somebody deciding to instigate a war in the Persian Gulf, that could definitely have a big effect on the price of oil. If you wanted to get it up to $200 a barrel, that might be a good way to go about it. But who would want to do that? Well, let's not go there right now. But so next technique, the expected value of information. So most of us, probably all of us, work with information, with data, and we would like to think that what we're doing has some value. Okay, but how do you decide what the value is of the information that you're gathering, cleaning, processing, analyzing, visualizing? What value does it have? Well, it's kind of a hard question, really, but decision analysis does have one way to think about it. So, and what makes it particularly hard is, if you want to make a decision about whether it's worth gathering some information or buying it or analyzing it, you really want to make that decision before you've looked at the information, right? After you've got the information, it's a bit late. But how do you know what its value is before you've looked at it? So we can represent our uncertainty about what the information will say as a probability distribution. So, for example, let's say I am trying to decide whether to, I'm a power company trying to decide whether to build a new power plant. And I want to know what the price of natural gas will be in 5 years or 10 years or 20 years. I probably want to know also if there's going to be a price on carbon, which there is a little bit in California, and probably will be, around the world in a few years. At least we hope so. But, that's kind of uncertain. And if you're a utility company, what are you going to do? So you could represent that uncertainty probabilistically, and then take and then for each possible outcome of that price of gas, let's say, we could look at and say, okay, what decision would we make if it's $2 a million BTU? What decision would we make if it's $10 a BTU? Maybe BTU plus the price of carbon, and then take a probability distribution of that. So that's why it's called the expected value information. Taking expectation, meaning taking the expectation of the distribution or the mean. So, but to use this expected value information, we need actually to formulate what we're doing as a decision analysis problem. So we need to express our uncertainty about the information in terms of probability distributions. We need to have a decision that we care about. Like if there's no decision, like why bother? And we need to have some objectives, something we're trying to minimize or maximize. So, but given all that, the decision analysis framework will provide a way to estimate the value of the information. Here's kind of a simple, an example. I guess I won't go into too much detail here. This is kind of a simplistic model, assuming you have a power plant that's emitting some kind of toxic pollutant and you're trying to decide how much to reduce the emissions, and you're doing a cost-benefit analysis. You're trying to balance the value of lives saved by reducing the emissions, by putting some controls on your power plant, against the control cost that you spend. Not everyone is comfortable in thinking about that kind of trade-off, but arguably you make that trade-off when you make a decision whether you think about it or not. So I would argue, we would like companies, we would like our government, we would like agencies to actually be explicit about that. People think about the social cost of carbon in a similar way. So, and there's a whole bunch of uncertainties in this quantity, in this model, uncertainty about how much it will take to control the emissions, what the concentration is, what the population exposed is, what the health damage function, for each increment in micrograms per cubic meter of this toxic stuff in the atmosphere, how many people breathing it will experience some kind of disease and potentially increased mortality, and is there a threshold? So those are a set of uncertain parameters, and it's kind of interesting to ask, okay, well, if we're going to do more research to refine, make a better decision, which of these things do we care about the most? So here, thank you so much. We're applying value of information to look at that. Can you tell me what time it is? Can you tell me what time it is?
Oh, I see. I'll let you know.
Okay, thanks. So, okay. So I'm now going to, this is kind of an outgrowth of this in a simplistic way, but I can think a rather important way. So imagine that you are building, a dashboard. I'm a bit literal-minded here, so I've actually got a car dashboard. But so you have a rear view mirror, okay? Let's look at that a bit close up. And so the rear view mirror shows us data from the past, because actually we can't see the future. Thanks. Cool. So if we're lucky, we might do predictive analytics. We might have some kind of GPS that tries to forecast, where things might be going, to assess trends. But this dashboard is kind of missing something important, and probably kind of obvious, but so a control, right? We don't actually care about where we've been or where we're going unless we actually have control over where we're going. So steering wheel can help. And that's kind of symbolizing what decision analysis provides in forming choices. And I mean, the point, just to belabor it a bit further, analytics have no value unless they help you make better decisions. Now, intuitively, I think we all know that when we think about it. But when your boss asks you to, do some analysis, develop some, look at some new data, how often is it clear what decision that might influence? Sometimes it might be just basic scientific research, and the decision might not come for a few decades. That might be fine, but ultimately, if it's kind of applied work, you'd like to have some idea that this is actually going to be make a difference in the world, and it'll only make a difference if someone is making decisions based on it. Okay, so I talked about some decision analysis techniques. I'd like to talk a little bit about decision analysis practice. Actually, this applies to any kind of analytics, not just decision analysis. And I've recently been saying, well, it's all about the relationship. So what relationship? So first we have the world, and we're modeling some small piece of the world. We're building some kind of computer model, statistical analysis, whatever, visualization, whatever it is. Okay. And then there's us, the analyst. Okay, and I'm the kind of guy, probably like many of you, I like numbers, equations, coding. Okay. And some of our friends call us geeks. I'm sure that they don't call you that, but anyway. So what's missing from this picture? So the client. So client, it could be your boss who, is looking to get some information analyzed. It could be, a whole bunch of stakeholders, many people in your organization. It could be, if you're a consultant, your actual client, which might be multiple people. And as important or more important in the relationship between your model and the world is this relationship of engagement between the analyst and client. And understanding what your client cares about. Maybe not even not assuming that they're going to tell you that they are clear about it themselves. Part of the job of the decision analyst is to help your client get clearer and about what their objectives are, what decisions are available, and so on. And so I say kind of to be an effective analyst, decision analyst, or actually any kind of analyst, you have to become an empath. Some of us naturally are good at that. Others of us have to work harder at it. Arguably, it's easier for the geek to become an empath than vice versa, although I've been told that was an inappropriate thing to say. But anyway, I kind of think that's probably true. I've certainly worked hard at trying to become more of an empath over my life, and still working at it. But I kind of recognize that, all us analysts, these soft skills are as important as the hard skills that we prize. So decision analysis practice has these elements of decision quality. This is a way to think about the process. So I'm trying to expose you to here that decision analysis is not just looking at the decision theory equations. It's like a whole lot more in terms of becoming an effective way of helping people make decisions. There's the framing. What do you include in your analysis and what do you exclude? You can't include everything in the world. You have to have an extreme simplification, but that framing is perhaps the most important decisions that you make as an analyst. The values and trade-offs, what does your client care about? What are the options? And that might not be obvious. Some creativity and ingenuity can go a long way to come up with better options. In many cases, that's the biggest value you can provide. Then there's what do we know? What data do we have? what are the risks and uncertainties, and are we thinking straight? Is our model sound? Did we code it correctly? And finally, once we have a decision recommendation, is there a commitment to execution? So, I think many of us have had the experience, we put all this effort into doing the analysis and we come up with some great recommendations and no one is paying attention. Or perhaps, a client already knows what they want to do, they just needed somebody to, put together an analysis to pretend that there was a good reason for it. So, I'm sure that never happens here, but anyway, so quality decisions, we actually have to look at all those 6 elements. So it's not simple, but there are techniques and practices that really can help. So the final thing I'm going to show you here at kind of practice, just, typically decision making is a kind of dialogue process. There's maybe a decision board, it might be a single client, or it might be a whole bunch of stakeholders, and then there's a analytic team. It might be one person or it might be a large team. And there needs to be this continuing interaction going through a series of stages, really to be effective, to get through all those 6 steps, 6 elements that we looked at. So, and I think influence diagrams we found they were designed by decision analysts originally as a kind of graphic facilitation method for problem structuring to help focus on the objectives, decisions, and uncertainties and identify them, because they have these different node shapes. Reminds us we need to think about which is not always as obvious as you might think. And most important, it's a tool for building a kind of shared understanding, trust, buy-in between the analysts and the clients. And that's just, that's even before you might decide whether you or not you want to use it as part of your software that you're building. It can be just something you use on a whiteboard. Of course, we at Lumina use it in our Analytica software, so we think it's also a great part of the software interface. So I'm going to shift gears for this last part. How much longer do I have?
We can do 1 hour.
Okay. Okay. So this last part is, I want to do a kind of case study. I'm actually, was thinking about which example I should look at, and I'm actually going to go back to one of the first decision analyses I ever did, back when I was a young professor in 1986. And it arose because I was having a debate about representations of uncertainty in decision-making. There was a conference on uncertainty in artificial intelligence that I helped found in the 80s, along with Yuda Pearl and Eric Horvitz and a few others. And initially, the participants were researchers, scholars, professors, students from a variety of fields, from philosophy, logic, AI, decision theory, statistics, who had a variety of different ideas about how to do this. There were rule-based expert systems, fuzzy logic. Lotvizadeh was an early participant, non-monotonic logic, Dempster-Schaeffer theory, and decision analysis and influence diagrams, and I'll group them with Bayesian networks and causal networks. And I got into this rather intense argument with another young professor. He was advocating for rule-based expert systems. They were really big in those days, especially at Stanford. And really they were the basis of kind of the first AI spring in the late 70s, early 80s, building these knowledge-based systems or rule-based expert systems. And the goal was to encode the expertise of an expert in whatever domain it was, a doctor or expert in corrosion or mineral prospecting, in the form of a set of rules with kind of heuristic numbers representing uncertainty and the guy I was speaking to saying, this is the easiest way to do it. And I was saying, well, no, I think, decision analysis is a better way to do it because we understand what the probability numbers, they have a well-defined semantics. There's a basis for rational decision-making, kind of a theory of what rational decision-making is about. So we should use that. He was saying, well, humans don't really think with probabilities, which is true for the most part. But, I don't know that we think with rules or, with, strength of evidence measures that were used in these heuristic things either. Certainly not with fuzzy logic, at least I don't think so, but there's no empirical evidence either way. The only empirical evidence is comparing human judgment with probabilities, and a lot of that behavioral decision theory work does exactly that and shows, yes, indeed, it's not a good model of the way we think. So, part of the goal of what I'm talking about here is like, well, are we trying to help people think the way they normally think, or are we trying to help them do it better? So, anyway, so we got into this argument, and to his great, and I was not the only one, many of these early conferences had a lot of arguments between proponents of these different methods, trying to decide, well, is it based on a sound theory of rationality? Does that even matter? Is it practical for knowledge engineering? If I go talk to my expert, can I easily encode his or her opinions, knowledge into this representation? And after I've done it, is it computationally tractable? So in this case, my interlocutor, to his great credit, said, okay, well, instead, let's not just leave this as a sort of theoretical debate at a conference. Why don't we do a bake-off? Come spend a week with him, and we'll each build a decision support system based on our own approach and compare it. I thought that was a really cool idea. He found an expert who turned out to be a plant physiologist who was an expert in apple trees. Who knows what you get into. And apple orchards are a $2 billion business these days. It's not a trivial thing. And this guy was an expert in advising orchardists how to handle their apple trees. It turns out that apple trees are susceptible to a variety of ailments, like everything else. And so we built this system. So things that can affect apple trees' health. Water stress, if the ground is waterlogged. Cold stress, if it's had a cold winter. Phytophthora. And you might not have heard of Phytophthora, but I expect many of you have heard of sudden oak death, which is an affliction of many of the oaks around here in California, and in fact, including in my own backyard, literally in the Santa Cruz Mountains, so something I care about. And that Phytophthora is a relationship to the one that attacks apple trees. So my colleague built this rule-based system. The dark blue things are things that you can observe, both is the ground waterlogged, and then on the right, reduced fine hairs, various things, and there's a test for whether Phytophthora is present. And these blue lines represent rules in the rule-based system. A bit simplified here, but just to give you the basic concept. And each inference rule, for example, this one says, if the Phytophthora test is positive, then the Phytophthora infection node is strongly supported. Pretty obvious. And then there's a decision rule here. If the Phytophthora infection is positive, then treat it with fungicide. Or treating with fungicide is strongly supported. So these rules were really provided by the expert. The nodes were identified and then encoded them that way. So the first part of identifying the nodes was basically very similar. Both my colleague and I did pretty much the same thing, but it's defining the relationships, the arrows, which was different. So I built what I'd call a Bayes network. So you'll notice that some of my black arrows go in the same direction, but some of them go in the opposite direction. Generally, they go in what I believe is the causal direction. I'd ask the expert, what causes what? So a phytophthora infection causes the phytophthora test to be positive, at least probabilistically, and we can represent that by conditional probability distributions. Now, of course, we want to do the inference in the other way. We observe the outcome of the test, and we want to update our belief in whether there's an infection. So that's what Bayes' rule does, essentially. You reverses the error. Then I built a whole influence diagram on top of that because I was interested in, what is the value to the orchardist of the various decision options, which depend on the damage to the tree, the cost of applying the fungicide, or if we replace the tree, put in a new tree, how much does that cost? How soon before the tree starts bearing fruit again? All this kind of stuff that you orchardists care about. And so it's kind of a very simple economic model, cost-benefit model. So then the moment of truth. Which system performs better? So, well, what does better mean? So my decision analysis system gave rather unexpected results. And I'm sure we've all had this kind of experience. We build our model, we do our analysis, we look at the results the first time, and there's that kind of, oh shit moment, that doesn't look right. So that's kind of what I had, was this oh shit moment. The expert in orchardist standard protocol is apply the fungicide if the phytophthora infection is likely. Pretty obvious, right? But the DA system said, in most cases, not all, just replace the tree anyway. So, the expert looked at that, shook his head, it's like, I think there's a bug there somewhere. So, could well have been, I create bugs as faster than anyone probably, but so I dig into the code, review the assumptions with the expert, making sure the numbers I put in were what he was telling me and the relationships were in the direction he told. So it turns out that fungicide is somewhat expensive to apply. It has side effects that also damage the tree and uncertain effectiveness. And in particular, a tree, even if it's cured, does not regain its full, doesn't recover completely and be a fully productive tree in terms of apple production. So, so it turns out in many situations, the cost-benefit analysis just says, hey, better to replace the tree. And this was not my idea, this was what the decision analysis was saying based on what the expert had told me. So, I went over this with the expert, make sure he understood it, see if I'd maybe misunderstood some of what he had told me. He kind of looked at it, agreed with everything, and in the end he said, now I think about it, now I look at these numbers, actually that's right, we should change the protocol for dealing with sick apple trees. So what can we learn from this case study from over 30 years ago? Well, I recently wrote this blog that Leanna saw called, what do we do when our model results seem ridiculous? Well, first we try to debug them. They might indeed be ridiculous. That's the most common case. But human intuition and expert opinion can be flawed, We've learnt that from all these researchers in behavioral decision theory. So we can't necessarily assume that human intuition or expert opinion should be the gold standard that we aspire to. I mean, we should listen to them, but not assume that everything they say is correct. But if we're going to have an alternative, we need something that we believe is sound, that's based on a clear process for rational decision making. And if you buy the axioms of decision theory, then that is true for decision analysis and probability. I also add in logic and arithmetic. Those are kind of important. I don't think most of us are pretty committed to correct logic and arithmetic, which is kind of underlying it. And then the last point is, when we find a bug, maybe it's in the model, usually it is, but sometimes it's in our intuition. Okay, and then the oh shit moment converts into, wow, okay, this was interesting. We should celebrate. We learned something new. Once we understand it, like the plant pathologist did, he gets a valuable insight. It improves his intuition. And, it's not like our intuition is fixed and lousy. It's like, hopefully, we're always trying to improve it. And this kind of process going through this decisionality model, going through this kind of cycle, hopefully we can become smarter. So let's see. I just thought so that exercise was, I hate to say this, but it was over 30 years ago now. So I kind of went back and well, what's the status of Bayes networks, probability and decision theory and AI today? Many of you may be aware of this. The UIAI conference is still going strong. They met in Monterey last year. This Artificial Intelligence, A Modern Approach book by Stuart Russell and Peter Norvig, claimed to be the most popular AI textbook in the world. I looked at it recently. 200 of its 1,000 pages are devoted to probability and decision theory or decision analysis. So, wow, that's cool. And Yuta Pearl, who developed the ideas in Bayesian causal networks, or was the leader in that field, received the ACM's, says ACP, but the ACM Turing Award back in 2011. So I think nowadays these concepts of probability and decision theory and so on are kind of so deeply embedded in parts of computer science, parts of AI that we almost take it for granted, which is great. It's how it should be. But for those of you who are wondering, well, what happened? This is what happened. It's around us. So, final slide. So, some people say to me, okay, well, given the success of big data and deep learning and all the stuff that many of us are doing, why do we even need to worry about this decision analysis stuff, dealing with humans who are so annoying anyway? Why do we need to keep ourselves in the loop? Well, we might have our black humor about welcoming our robot overlords, but I hope that we, well, you guys actually are going to deal with that. That's not really where we want to go, because we're trying to help improve things for us humans. At least I hope we are. And so one reason we need humans in the loop, we can't just, even if we tell our AI systems to do what we want, we have to tell them what we want, right? They can't figure it out. So we need to define our values and preferences, the stuff that we care about, in a way, and express it in a way, in a formal, structured way that, the AI can deal with. And, decision analysts have a lot to say about good ways to do that. And, the decisions are not obvious, a lot of times the biggest value a decision analyst has is to come up with new decisions, usually in a kind of brainstorming with the stakeholders. So identifying and inventing better decision options. Yeah, maybe software can help in that too, but it's kind of something that humans are definitely going to be involved with. And then the last point is kind of crucial, which is, let's go back to the other. So imagine that, we had a huge amount of data about apple trees, from orchards all around the country, all around the world, which ones flourished, which ones don't, under what conditions. Okay. Could we build an expert system from that? Well, we couldn't unless we've defined the values and preferences of the orchardists that manage those. That needs to be in there. This last point is kind of more salient, let's say, from the power plant, the power company. So imagine, go back to, we're trying to decide whether to build a new power plant. How much power should it produce? What is the growth in demand going to be over the next 10 or 20 years or 30 years? Are electric vehicles going to become really popular soon? So demand for electricity is going to go up. Are we going to find ever more ingenious ways, methods of energy efficiency? So actually we can get all the services we want with a whole lot less electricity. How are those things going to interact? Those are things that looking at past data is not going to help us much with, because things are changing. Things are unprecedented. We're facing technologies and politics and future that we just can't learn about just looking at the past. So we need humans' ingenuity to think about these possibilities and to think creatively about what are the possible scenarios. How can we develop decision strategies that will work? We're not going to be able to remove the uncertainty, but we can express it explicitly. We can look at a range of possibilities, let's say, in terms of the growth of energy demand. And similarly, for which technology we want to choose. Do we want to use gas or PV or wind, or wait for something else? Or battery's going to do it. We need to think about the future. We can't get this just from the past, and we need creative people, and we need people who think widely, and to generate these scenarios, and then ultimately to try to assess the uncertainty, preferably using probabilities. And so, these are all things that, our AI is not going to be able to do anytime soon, nor should we really hope for it. But with the right software, it can help us augment our intelligence in all these activities and a whole lot more. So thank you.
Okay, so open for questions. Anybody have questions?
Thank you.
So what I'm wondering is, this seems to be very naturally applied to medicine, and I can't say that I've ever seen it being applied. I was wondering, is it, and if it's not, do you know why?
So is decision analysis being applied in medicine? Well, so the answer is yes, although maybe not as widely enough for you to have noticed it. So there are departments and decision analysts at some medical schools, I think including Stanford and a few others, which try to apply these techniques in medicine. And also there are Bayes networks that underlie some of the automated diagnosis and recommendations that are starting to become available. So So yes, some of this technology is starting to be there, and I think, well, there's different views about, well, surely it should have gone further by now, but there are activities there, yes. And I'd say, when I started out doing a lot of this work, I was actually working in medical informatics at Stanford for a sabbatical, and there were a whole bunch of people active in applying these decision analysis in medicine. Many of those people, like Eric Horvitz and David Heckerman and others, kind of have gone on to other domains because they found medicine was kind of moving rather slowly, but it is moving. Yes?
Just to follow up on a previous point that was just made about artificial intelligence in medicine. There's a really good book out there called Deep Medicine. I don't know if you've heard of it. Written by Dr. Eric Topol, who's down in San Diego with
Uh-huh.
students. It's really good. If you want to understand, I think he's really intelligent. If you want to understand, really informed on the subject. If you want to understand where deep learning and artificial intelligence is and where it could go and the problems and issues, I highly suggest that book. It's called Deep Medicine.
Thanks so much. Appreciate that.
So you mentioned fuzzy logic. To what degree does fuzzy logic and linear algebra influence what you do? Or what sort of overlap do you see?
Well, to be honest, I don't, back in the day when the conference on uncertainty in artificial intelligence was getting going, Lotfi-Zadeh, the originator of fuzzy logic, and some of his disciples were very active in that. I have not heard much from them recently, but maybe I just don't know.
Hi, yes. I have a question about when you build these models, and do you fit can you fit those probabilities to a large amount of data, or is that put in by hand by human experts usually, or is it a combination of both?
Well, I would say it's a combination. I mean, if you have data is great.
Repeat the question.
Oh, sorry. If you have data, can you fit probability distributions to it? Or do you need to use expert judgment or a combination? And I would say, well, a combination. And if you have data, it's great. But the thing is that, think about this issue of projecting electricity demand. Now, there's a huge amount of data, looking back historically, and there are excellent models if you want to predict electricity demand, next few days, maybe up to a year or two. Because you can do that pretty reliably based on past data, projections of the weather, maybe partly depend on economics. But going out beyond a year or two, you're dependent on changes in behavior, changes in the economic growth rate, changes in energy efficiency, and data starts to become less and less relevant, and that's why you need expert judgment at that point. And kind of but there could be a kind of graded combination as you go further into the future. It's more going to be based on judgment. I mean, lots of people try to avoid judgment and just, fit nice regression lines on the historical data and draw them out for 10 or 20 years into the future. But, I don't think that's really a good way to do things. I mean, it's been demonstrated that it is not a good way to do things. Yes?
What are some of the dangerous mistakes that you have seen in applying decision analysis?
What are some of the dangerous mistakes I've seen in applying decision analysis? Wow. Well, I mean, in describing those 6 elements towards getting a good generate, good framing, identifying decisions, clarifying the data, clarifying objectives, having a solid model without bugs, and then commitment to action. So each one of those 6 things can be done well or badly and give rise to mistakes. And I guess I've seen probably just about all of those. And sometimes it's, this is difficult stuff to do. Probably the biggest challenge, I'd say, is kind of that relationship between the decision analyst and the client. And having a client that actually wants a decision analysis performed as opposed to just wanting justification for a decision that's already been made, let's say. Ideally an ethical decision analyst won't go into that situation, but sometimes it's not obvious. So, but I'm sure there's more that could be said, but maybe I'll move on. Any other questions? Yes?
Some AI methods use regret minimization. Is that typically used in these type of systems as a desired, for the decision-making process, or is that?
Sorry, minimax?
Regret minimization.
Regret minimization. So minimizing regret is, I guess I would view it as kind of a heuristic that in some situations works pretty well, but in some situations is not really good approximation. There's multiple objectives. I mean, we as humans are much more, pay much more attention to bad things than good things. I mean, we tend to worry more about the things that could go wrong and feel more unhappy when they do. Let's say, if you lose $1,000 versus you get an unexpected $1,000, somehow we feel worse about losing things than gaining them. And there's lots of psychological research that shows that to be the case. And, there's evolutionary arguments that explain why that might be the case. And the focus on regret, which is kind of where we, did something that turned out badly, is a natural human thing to do. But I would say one of the tasks of decision analysts is to try to reduce that effect and not have us dwell overly on regret compared to possible gains. It's not to say that it's irrational to be, to see a loss of $1,000 or $1 million as worse than a gain. That's, there's a risk preference, a risk function that lets us represent that. But what we see is kind of really excessive, and when you kind of show it to people, irrational focus on regret. So, and there's criteria, for example, used in Europe to some extent, the precautionary principle, which says, especially applied to new technologies or new drugs, don't do, if you think there's a danger from this thing, then, err on the side of caution. I mean, maybe putting it like that sounds reasonable, but if it's like, don't do something if there's any chance that it could turn out badly, that might mean you're losing out on a lot of things that could turn out well. So again, it's a matter of trying to clarify our biases and see if we really buy into them when they become clearer to us. Yes?
It seems that where the problem space is extremely huge, even for computers, that's where human intuition still seems to stand strong. I'm thinking of one example. For example, the Fed Open Market Committee is a bunch of humans, not a bunch of software. And I think it was Milton Friedman who said that, they should be replaced by a computer, but it hasn't happened. And it's probably because the problem space is just so huge that human intuition still seems to work there. What do you think about that, where problem spaces are extremely huge even for computers?
Well, I guess, I mean, certainly we are oftentimes working in incredibly complex situations. You know, in that case, you know, do we know, you know, what's the alternative? Do we know that the people at the Fed making those decisions are doing a good job? I mean, compared to what? You know, I think it's hard to say, but I wouldn't be too sure that we couldn't come up with a better way to do it. I mean, it might be humans doing it in a better way, better humans, or humans with getting different kinds of information, looking at different kinds of things, being subject to different kinds of pressures, political pressures, or ways to ignore them. You know, there might be ways to improve it like that. But, you know, I mean, there may be examples you can come up with where human intuition really does seem to do outstandingly well, but I'm not sure I would select that one, because we don't know.
How do you model uncertainties? Is that where I think human intuition comes in? The uncertainties, I think, is modeling better than humans.
Yes.
There's a kind of projective or the models with the data. Whole data may not give you the uncertainties. Modeling uncertainties.
Yes. Modeling the uncertainties
Yeah.
may not give you...
No, the older data will not give you anything about the uncertainties in the future.
Right, right. If we just look at past data, you know, is that going to tell us about how much uncertainty there is about the future? I mean, that's a great question. So I did a study recently with a PhD student at Carnegie Mellon, Evan Sherwin, looking at forecasts of made by Department of Energy, forecasts of the energy system, forecasts of energy prices, you know, quantities of electricity and gasoline and oil and coal that we use. And we found that their projections over the last 10 years were far worse than they had been in the preceding decades. So one possibility is that DOE's models just got worse, but I don't think that's the case. I think the energy economy system that we're operating in became more volatile and more unpredictable. So, you know, and looking into the future, do we think things are going to become more predictable or less predictable? I guess, you know, I predict that they will become less predictable. So, I mean, the solution to that is, you know, we're never going to, you know, we're not going to be able to say more exactly what the price of oil is going to be next year or in 10 years or 20 years or the amount of electricity, but perhaps we can do a better job of looking at the range of possibilities and developing more robust strategies, more resilient strategies that work.
A simple case would be like how the infrastructure has been built so long.
Right.
How the enterprise infrastructure has been, like everything's changed.
Right.
Now the cloud came in and disrupted the whole thing.
Right.
The cost has become completely never predictable.
Yes, yes, absolutely. Thanks. Yes.
You have a question? You first.
The human decision making is based on how human is storing the data and retrieving. But all our computer systems are based on, like, starting from telegraph systems. We are using
Starting from?
telegraph, we are using dash and...
Starting from telegraph.
Telegraph, yeah.
Dot and dash. Even today's computers, we are using only two states, like on and off, 0 and 1. So any thoughts or recommendations to improve it, like how we store, retrieve, that way we can take preparation, like humans?
Well, I don't think I'm the expert on that. I mean, yeah, there are people who have been said that the human mind, well, notably, I think Penrose, that, you know, there's some kind of quantum effects that affect the way we think. I mean, I don't know if there's any evidence for that, but I guess I'm not qualified really to say much about it. You know, there's people that think, well, once we have quantum computers, you know, we'll be able to deal with uncertainties better. I kind of, well, maybe, but we'll be able to do all kinds of things, perhaps. But, you know, I don't think we have to wait for that to start trying to deal with uncertainties better today. I don't think it's a matter of, you know, the limits of our computers, really.
Okay, I guess the last question is the Lumina hire. What kind of people you're looking for?
I'm sorry?
Is your company hiring?
Oh, absolutely, yes. We are, thank you. We are looking for you know, software developers interested in this kind of work, interested in trying to, you know, build better tools. People with AI background and just regular software background. And we're also looking for people that are decision analysts or want to become decision analysts and have a kind of good quantitative background skills in a variety of areas. Yes, thank you.
Yes. Okay, let's give a round of applause.